All right, today we're going to talk about polar coordinate system. We're going to be converting polar coordinates to rectangular coordinates and vice versa. So rectangular coordinates are something you're familiar with. Rectangular coordinates are just x and y on a regular xy plane. Now polar coordinates, all that is going to be converting it. So polar is going to be r and theta. There's going to be two of them. There's going to be a negative r as well. So when you find the first one, most of the questions that you're going to be you have in Canvas are all going to be they're going to tell you r is positive. So it's really straightforward and easy. But if they wanted the second one, you would have to extend it, and it would be the other one would be negative r, and then whatever angle is represented by that. And I'll go over examples to illustrate that. But a couple things that we need to know from previous topics that from trigonometry that x is r cosine theta and y is r sine theta. We did a good job deriving that from the trig equations where we knew that the cosine was adjacent over hypotenuse, and we knew the hypotenuse was the radius, and the adjacent side was x, and then we solved for x. Same thing with sine. We know the sine was opposite over hypotenuse. The opposite side was y, and the hypotenuse was r, and we solved for y. The other one is the equation of a circle at the origin. We'll be using those three throughout this lesson. So make sure to keep those equations handy. The first thing we're going to go over is an example. We're going to convert All right, so the first thing, we're going to be converting from polar to rectangular and rectangular to polar. So if we're given a polar coordinates, we want to convert that to our rectangular, which is x, y. So now all you need is your equations. X equals r cosine theta, and y equals r sine theta. And then you plug in the information. This is your r, this is your theta. So substitute those in. Then you should be able to find the exact values of those. If you remember from trigonometry section previous. 7 pi over 6, this is pi. Zero and 2 pi is right there. So 7 pi, this would be 6 pi over 6, so it's another pi over 6. Okay, which is 30 degrees as well. So you should know that the x value is negative there, and is the y. Okay, negative, negative. Cosine and sine is both negative if you remember all students take calculus, or you just look at the coordinates and it's negative and negative. And we should know the cosine of that reference angle of pi over 6 or 30 degrees is square root of 3 over 2, but it's negative. So we get the x coordinate to be negative square root of 3. And then we find the y. We should know. Oops, I keep writing this over. Y equals 2, and then the sine is 7 pi over 6. The reference angle is pi over 6 or 30 is 1/2, but it's negative because the y value is negative. And we have our rectangular coordinates. And that's all you have to do for that. Now we're going to convert from polar to rectangular. Now, anytime you do that, you're going to have two of them. But again, most of the assignments in Canvas, you only have one. So, all right. So the first thing you should do here is plot the coordinates on the xy plane so you can find the radius and the angle. Sometimes you need to use inverse trig functions to find the angle. But this one's pretty straightforward. Negative 1 is right here. So we should know if the legs are the same length, that the angle is going to be pi over 4 or 45 degrees. And to find the radius, you could use Pythagorean theorem if you want. And it's always going to be plus or minus when we talk about the radius. This one's going to be positive. The first one's positive. So you're going to get positive square root of 2. And I'm going to say negative pi over 4. If you want, you could also write 7 pi over 4 if you'd like. They're the same angle. Okay. Now, again, polar coordinates have two values. So we're going to extend this. Okay. And it's going to be the same thing, but it's going to be negative 1, 1. Okay. And the radius is going to be negative on this one and the second one always. Same reference angle, pi over 4. So the other one is going to be negative square root of 2. And then that angle is pi over 4 short of pi. So if you want to convert that, you do pi minus pi over 4. Get a common denominator. And you get 3 pi over 4. Again, most of the time on the Canvas assignments, you only need to find the positive one. So it'd be one of those two answers. So that's how you convert those. All right, next one, converting from polar form to rectangular form. Now you got equation R equals that. First thing I'm going to do is just try to isolate the number because a lot of times that's going to be the value. So I'm going to divide by secant, which is the reciprocal of the cosine function. And so we know that 1 over secant is the cosine, so it's our cosine theta, which is 2, which our cosine theta we should know is x. So that's the rectangular form. Now we're going to convert from rectangular to polar. We have the equation. It's a circle. The first thing we're going to do is go ahead and calculate what x minus 2 squared is. I showed you the shortcut. You square each one of those terms, then multiply the terms, and then multiply by 2. Or you could use the distributive property, do x minus 2 times x minus 2. But that gives you that, plus y squared minus 6y plus 9 equals 13. Next thing you're going to do is bring over the constants. So I'm going to subtract 4, subtract 9, and that'll give me 0. Now we should know that x squared plus y squared, so I'm going to write them together, is r squared. You want to get rid of the x's and the y's. That way you could go ahead and put it in polar coordinate form. This is equal to the radius squared. X is our cosine theta. And y is our sine theta. So we just substitute those in. And then we're gonna factor out the greatest common factor, which is r here. And then we set each of the factors equal to 0. R equals 0, which is not a point. So we can't have an angle if it's at the origin. And then you're gonna solve for r. You're gonna add 4 cosine and 6 sine, so r equals. And that's your answer. Now I'm going to go over a couple of the problems from the assignment in Canvas. All right, we want to write the rectangular equation from this in polar form. So we're going to convert from rectangular to polar. Again, we just got done doing this problem. X squared plus y squared is r squared. And we know x is our cosine theta. And so we look, and it's an easy problem to do. Where is it? We factor out the r. That's not possible. as we did in the previous problem. And then we can solve this by adding 2 cosine theta, and that's our answer, which is right there. Very similar to the previous problem. The next example, write the equation in rectangular form from polar. Okay, this one's a little trickier because we don't have r sine theta here to convert. So what we're going to have to do is we should know y equals r sine theta. So we're going to solve for sine so we can substitute and get rid of the sine here and put it in rectangular coordinates. So I'm going to solve for sine, divide by r, so y over r equals sine theta. I'm going to substitute that in so we can get rid of it and we can convert this. So r equals 3, and then I'm going to substitute in y over r. Now, there's not much we can do here except for multiplying by r. So you get r squared equals 3y. Now we have the y. Now we got to convert r squared. We should remember r squared. Again, those 3 formulas that I told you you're going to be using. And we substitute that in for x squared plus y squared, the equation of a circle, and then we subtract 3y. All right, so now we're going to convert from polar, to polar from rectangular on this. So I'm going to plot. Again, we should know the legs are the same length, so that's going to be 45 degrees. So that angle, again, this is pi. So it's going to be 45 degrees, pi over 4 more than pi, which is going to be, if we convert it, get a common denominator. I'll show you that, is the angle. So this is going to be the positive one. This one will be the negative one. Okay. Again, the first one's always going to be positive, and then we just draw a straight line to get that angle. We know this is going to be pi over 4. And then we find the hypotenuse, the radius. The radius is going to be 3 squared plus 3 squared. Take the square root of both sides. That's where we get the plus or minus. And we know that we could simplify that. 9 times 2 square root of 3. 2 over 9 is 3, I mean, and then that. So our two equations, this one's going to be the positive one. So you're going to get 3 square root of 2 as your radius. And your angle there was 5 pi over 4. And it only wants r greater than 0, so that's your answer. If we wanted the negative one, then we would write this one in. So those are your two polar coordinates. The next example. So when you just have r, you can't really make much of adjustment there, so you got to square both sides. And then we know r squared is x squared plus y squared equals 9. And that's pretty straightforward. Next one. Okay, so now, again, polar to rectangular, r squared is x squared plus y squared. R sine theta is y. And that's it. All you got to do there is convert. This one you got to convert and then solve for r. So you're going to divide by cosine, and it's going to be one of the reciprocal ones. You're able to do that. We talked about that quite a bit. And a lot of them are repetitive. So that'll be it. And if you have any questions, please message me on Canvas.